Please do not fall asleep. I know it's the first presentation of this afternoon. So the title of my presentation is How to Detect, Treat and Prevent Biofilm Contamination. So you understand, we will talk about biofilms. And you know also that outbreaks can be a nightmare. We talk about crisis. We talk about impact that a crisis can be for you as cost, for your customer confidence, but also in the image of your company. So definitely something you want to avoid. And once again, here we are talking about contamination related to biofilm. For us, it's very important to distinguish contamination related to biofilm and contamination related to the product itself or the water, etc. So we will make a strong focus here on understanding, does my contamination has a link with a biofilm? So to do that, I will introduce biofilm. I'm sure you know what biofilm is, but some highlights. After that, we will review together some techniques and way to identify biofilm, dismantle biofilm, and prevent biofilm. And I will finish with 3 industrial cases in the dairy industry. Does it fit for your what you need from this presentation? It's the time now you have to show that you're awake. Yeah, thank you very much, guys. We continue. So first, definition about what is a biofilm. So in fact, biofilm is microorganisms with a protective layer. Unfortunately, that protective layer is very tough to eradicate thanks to standard solution. And this layer is composed of different ingredients. It can be DNA, it can be fat, it can be proteins, it can be polysaccharides. So a lot of various ingredients that are together, and that's why it's different to dissolve this matrix. Inside the biofilm, you have some microorganisms that are happy to live. They collaborate together, and they continue to survive to cleaning and sanitation, okay? So when you talk about biofilm, we talk about biofilm growth cycle. It always starts with some planktonic cells. They are present in your facilities, in the water, in the air, thanks to the operators, thanks to the ingredients. So it's not possible to avoid microorganisms to enter into your facility. And once they are there, they will try to fix on surface, multiplicate, protect themselves against mechanical aggression, chemical aggression, etc. So it's very important to understand that once they are there, they will grow, they will continue to grow, they will arrive to the step number 4, when is the spreading. Spreading of planktonic cells or fragment of biofilm. So it's important to understand that in the 3 first steps, you don't see the biofilm because it's not transferred to your finished product. When you are at step number 4, okay, you have microorganisms in your finished product, and then you can see them because you analyze your finished product. Okay, so you can have biofilm, but sometimes you don't see them, and you cannot locate them. Some key facts about biofilm. So it's a common behavior of microorganisms to produce biofilm because they want to protect themselves. And vast majority of the microorganisms are capable to produce biofilm or live inside the biofilm matrix. Once they are in the biofilm, they are more resistant to sanitation because they are under a protection and also because they are under stress. So they can resist to higher aggression. If you apply, for example, 200 ppm of active chlorine or 500 ppm of peracetic acid, if there is a biofilm, you will not kill those microorganisms that are under the protective layer. So that's not enough. It's also some studies saying that foodborne illness have a link with a transfer from equipment to the product. So it says even if you have a very high quality product, you can have a transfer from the equipment when you process the ingredient into the finished product. So you have to manage and avoid those biofilm to be present in your equipment. Biofilm is underestimated because sampling techniques are not fully effective against biofilm. We will review that together. But also because inside the biofilm, because of the high density of microorganisms, they are under stress and it can induce the viable but not culturable state. So it means if you apply some specific resuscitation condition, maybe you can see those microorganisms, but if you don't do, maybe they will not be visible in your routine test. Important to know that. Also some studies saying that you have to use enzymes in order to dismantle this matrix, and it works quite well. So all those studies are present, so you can have a look on those ones if you want to further understand what does it mean and what are the impacts. And you can see that video that biofilm goes quick. It's not a question of 2-3 weeks. In a few hours, in good condition, microorganisms will be protected. So it's too late. Step number 1 is done. We are on the step number 2 and 3. Okay? When we talk about biofilms, many germs are capable to produce biofilm. You can see those ones. You know them. They are present in the dairy industry. And it's also important to understand that those ones in bold are the ones that are capable to produce a very specific and tough polysaccharide. It's what we call the PNAG. The PNAG is very difficult to eradicate thanks to specific standard solution, and even with enzymes. You have to use very new enzymes that are present now in the market to deal with the PNAG protection. So, and you can see that, for example, E. coli is producing PNAG, and if you apply standard solution, it will not work. You will not kill and eradicate the matrix. Inside the biofilm, obviously, you have some microorganisms that are not biofilm producer, and they will be happy to live together. You can have phages, you can have virus, you can have yeast and molds. So it's a community of different kind of microorganisms, and all together they collaborate. Many scientific studies are saying that if biofilm is present, sanitation doesn't work, and it's very critical to try to eradicate this matrix, protective matrix, and after that you do a sanitation to make the sanitation more effective. Now some symptoms, and I'm sure you know those ones. Product recall, unstable microtrends, or off flavors. It can be also stress tests that are positive. So all those information, all those symptoms must highlight in your brain that, okay, maybe I have something that I'm not capable to manage, and I have to understand why is it present. Metagenetic also is a good tool. For example, if you take a good product and a defective product, and you analyze the flora, you can say, okay, it's different. Something is different. Okay, it can be related to a biofilm. So this was to introduce biofilm. Now let's talk about the methods and technique for biofilm eradication. Unfortunately, I will not say that there is one specific tool that works in each case. So at Realco, what we do, we combine different kind of analysis in order to try to understand which one works in my case, which one works in my production site, which one works with the microorganisms I have. And it can be microbiological testings. Obviously, it works. It can be molecular biology, metagenetic, you know. It has been introduced this morning, so it's good information to know, okay, what kind of germs I have, what they are coming from. Is it the water? Is it the raw material? Is it the environment? So it's very interesting to understand which one are present and create a link between the finished product where you have an issue and where they are located in your food factory. If you can do that, you can act on the biofilm and avoid this biofilm to ruin your production. Biochemical tests like ATP, EPS matrix, so it's possible to color the biofilm to make it visible on open surface, and physical tests like UV light or flow cytometry. I will review those examples further in the presentation. But it's very important to understand that you have to combine all those information because they are telling different stories and give you different information. So the process we recommend is first you do a detection. It will be different for open surface and closed circuit. After that, we characterize. We try to understand what kind of germs I have, to understand where they're coming from. You treat, so you eradicate the biofilm, and you prevent this biofilm to regrow again. Because microorganisms are present, you cannot avoid that, and they will start to regrow and maybe pollute your production site. Let's talk about detection. Detection will be different for open surface and closed system. Here, in open surface, what we like to use is UV light, for example, or biofilm coloration. So we can color the EPS matrix of the biofilm. The goal is to make them visible and be sure that you do the testings where you have some something that resists to cleaning and sanitation. We always do the audit after a cleaning and a sanitation session, just before restarting production. Okay? And you can see here, that's obvious that, okay, it could be good to swap those areas where it looks to be present. Otherwise, maybe it will be a fail, but it's not a good information. I'm not talking about the routine test. I'm talking about investigations. This is for open surface. For closed system, I would like to introduce what for us is a reliable sample. You have two pipes. The red is the biofilm, and the spots are the planktonic cells. On the top one, you have some planktonic cells that are present via the water, for example, and you have those released by the biofilm. And you can see that if you take 3 samples, so you have a sampling valve, you take the water from the pipe. It's an image, so it's, I would like to simplify. But you can see that sample 1 is contaminated, but low contamination. Sample 2 is higher contamination, and sample 3, you don't see anything. Because you are not lucky, you don't trap some microorganisms from the system. So you only take into consideration planktonic cells. You don't take into consideration those ones that are still in the biofilm. So it's for us only, it's not a reliable sample in a closed system. What we do, we use our enzymatic solution to dismantle the biofilm, release all the habitant of the biofilm, and then you have a more effective sampling method for those closed circuits. Otherwise, you don't see them. Okay, so for us, it's very important. And on all those, so yes, you see consideration of all bacteria. On the samples we collect when we do the enzymatic treatment, we can apply different techniques in order to understand what kind of bacteria I have. Do I have some biofilming bacteria? We can use also the metagenetics to understand what kind of flora we have, what kind of germs we have. You can also understand where they're coming from, water. Is it the raw material? Is it the equipment? So it's better information. We are using also some growth media. There are some specific growth media that allows biofilming bacteria to grow and be visible. So there are different techniques that we are combining in order to say, okay, in terms of ATPmetry, I have a big raise when I use my enzymatic solution. Okay, what about the cytometry? Cytometry is counting the cells. No, it's not a cultural media. So we have different information, and if you combine all those information, you have a good understanding about, in this place, in this equipment, do I have something that is present? To make it a bit more understandable, so we take 4 samples. So we ask customer to clean and sanitize an equipment. We circulate water in the system. We take a sample. This is our T0. After that, we load the enzymes in the same solution that circulate in the equipment, and we take two samples during the enzymatic phase, and we take a final sample in the last rinsing water after sanitation. And we are going to compare those samples. You can see here that we have an increase. Here is the ATPmetry, cellular ATPmetry calculation. You can see that we have an increase by more than 1 log from samples taken before the enzymatic load and after the enzymatic load. So we say, okay, we are extracting something. And if we combine that with a metagenetic analysis, we see that the flora is totally different. So, okay, we have a deeper understanding about, is this equipment contaminated via a biofilm or not? And the idea is we do that on different equipment, and we see those ones that are critical and those ones that are under control. So it helps us to understand, okay, we locate the biofilm on that equipment, we need to further investigate why this equipment is contaminated by a biofilm that is resisting to the sanitation we apply, the cleaning and sanitation that we apply on this equipment. Okay? And sometimes what we have also is the initial water is contaminated. And I say, guys, do you know that you are cleaning and you do the final rinsing with a contaminated water? What? So sometimes it's the case. So it's very interesting. So it helps us to understand the potential root cause of the contamination and locate the biofilm contamination. So let's talk about the treatment itself. So when you talk about enzymes, You know that you have enzymes for cleaning and enzymes for biofilm. And now you understand that those ones for biofilm treatment are totally different than those ones used for cleaning, because we have to act on those polysaccharides, DNA, and things that are a bit different if you take into consideration enzymes that are needed for cleaning. So those enzymes are capable to dismantle the biofilm matrix and release the bacteria that are inside the biofilm matrix. You know what enzymes are. So it's a protein, it's green technology. What is good also with enzymes is it's fully effective at neutral pH and temperature about 45 degrees C. So it means that the solution we take when we do the enzymatic dissolution is not too aggressive for the microorganisms. So we can use that solution to analyze what kind of germs we have in the solution that is supposed to dissolve the biofilm matrix. Okay, so it's not aggressive for equipment and also for the microorganisms. So what does those enzymes, how they are effective on the biofilm? So you have, from the left, you have what standard solutions are doing. On the right, you have what enzymes are doing. The goal of enzymes is to go deeply in the biofilm layer, dissolve the layer, and you can see on the bottom, on the right, that you have some spots. And these are the initial bacteria that are sticking to the surface. But now they are available for the sanitation. So if you apply a sanitation, it's planktonic cells. So you can kill them. Before, without any enzymatic dissolution of the matrix, it's not possible to eradicate the biofilm. So this is the way for us to act on the biofilm and dissolve and kill those microorganisms. I'm not saying that you all have biofilm resistant biofilm in your facility. Some biofilm are easy to deal with water, with alkaline-based products, but we act on those ones that are resistant to standard solution. So if you are not capable to get rid of biofilm via standard solution, okay, it's maybe because it's a biofilm that resists to those CIP and SIP. Okay? To prevent, so on the top you see what happens with the 4 stage of the biofilm growth cycle. And when you are at the end, you have you see the contamination in your routine test. The idea is we start with a curative treatment. This is the red line. We go to a 0-level biofilm contamination. Unfortunately, it's not possible to avoid those germs to enter into your process. So we will try to follow and monitor this biofilm regrowth. How can we do that? For example, it can be you do some stress tests on your product. As long as it's okay, we have no pollution of your finished product. When it restarts, okay, we can say, okay, it's too late, we have to do a preventive treatment. Or you can follow total flora, or you can follow some specific germs, or you can follow the complaints. Sometimes it's not possible to highlight some criteria to say biofilm is present, it's more the complaint. Okay, so you have to define your own criteria to say, okay, it's the right time to do a biofilm preventive treatment to avoid step number 3. Okay? We can discuss that together, and we have many examples. Now let's go to the industrial case. We are in the dairy business. We know that food safety is key. This is an image of the process from farm to fork. And we have decided together to present you 3 industrial cases, one on heat exchanger, a second one on the dosing system, and the last one on the membrane equipment. This first one is a company called us because they were facing some sporadic contamination, and it was 20 contamination during 2 years. And they asked us to investigate where this contamination can be located. We went on site, we did some audit on closed circuit, so different lines, tanks, but also we investigate the dosing system. And we asked them to dismantle some part of the equipment, and you can see directly that some parts were not clean, and it was done after the cleaning and sanitation, before restarting production. And you can see that thanks to the UV light, some parts were not fully clean, so we asked them to do a swab there, and there was some contamination there. Okay. They continue to investigate because after the treatment, it was not finished. They still had some contamination. And they understood that some part of the equipment the the design was not okay, and they found some, in fact, a real biofilm. They act on that biofilm, they modify the design of the equipment, and now it's done. So I'm not saying that every time biofilm is there and you cannot cope with a good cleaning and a good equipment, but sometimes you miss one information, and if you do an investigation, you can understand, okay, this is where I have the issue, and I have to understand why this issue is still present. And sometimes it's a question of hygienic design. It's not a question of biofilm that resists to cleaning. It's because the design is not okay, so the cleaning is not okay. Okay, but in the time between finding the solution and when we were there, they implement a mitigation plan to increase the efficacy of the cleaning thanks to enzymes, and it helps them to be safe for 6 months. And after that, they changed the design, and it was more okay. Okay, so it's a negative test for us, but it's interesting to understand. It's important for you to understand that you have to investigate more, and you have tools to do that. UV light, for me, in open surface, is very effective and very easy to handle. Second one is a plant heat exchanger. So it's typical for us to find some biofilm on that kind of equipment. And you can see that that company was facing some specific germs present in the pasteurized cream and milk. They asked us to come on site, and we did an audit on this equipment, and we confirmed that there was some organic matters that are present in the system, but also some biofilms. So we asked the company to do some weekly intensive cleaning based on enzymes, but here I'm talking about cleaning enzymes, so it's more lipase for fat. And also they implemented quarterly treatment for biofilm prevention. And now it's done, and you can see that the trend is totally different before and after, because the equipment was contaminated with the biofilm and was polluting the product during its process. And this equipment is supposed to reduce the amount of germs, and sometimes it's not the same, it's not the case. The last one is the filtration equipment. That company calls us because they had some issues with the product, and you can see that it's a pre-cheese filtration equipment, so the equipment is treating pre-cheese. And they had some contamination that was changing the properties of the product. And it was impacting the further step of the process because the product could not be used anymore. We went on site and we did an audit. And for the filtration application, we have an audit in 3 steps: organic fouling, inorganic fouling, and biofilm fouling. So we investigate, and we understood that proteins and fat were present in the equipment, so they had to reinforce the cleaning, but also they have to take care about the biofilm because biofilm was growing in the equipment. And you can see that since we implement the treatment, they have no problem anymore. And here they are following the efficacy of the treatment thanks to the thermophilic bacteria that they can follow. So they can monitor those kind of bacteria, and it's a good tool for them to say, okay, as long as we are okay with the thermophilic bacteria, we are controlling the biofilm. When it goes up, we have to do the biofilm treatment. So here they have a KPI to monitor. Okay, so these are the 3 examples I wanted to share with you. We have many others, so do not hesitate. But it's very important for us to give the capacity of the customer to deal with those biofilm and find a solution that makes a difference. So if it's not good before, it has to be good after. Otherwise, we have to continue to investigate. Maybe you are closing doors. Sometimes you say, okay, it's a biofilm. Sometimes you say, no, it's a water. So you have to change that. So it can be different kind of conclusion. Take-home message. So biofilm can be everywhere in the process. They can cause quality and safety issues. They are not detected thanks to standard sampling methods, and they are not always destroyed by caustic and acid products. You need sometimes to reinforce your cleaning if you want to deal with biofilms. But you can deal with biofilms by using a specific monitoring plan. Thermophilic bacteria, for example, in the last example. You need also to adapt your detection methods. specific detection method for biofilms, and by introducing some periodic enzymatic treatment to make those bacteria available again, otherwise they will be under the protective layer and you will not reach them. This was the goal of my presentation. I hope you enjoy it just after the lunch. Thank you.